Now, in this particular course, we are going to learn new spinning technologies. Let us first see what are the different technologies that we have. First one is open end spinning. The next one is the wrapping, that is spinning a yarn by a process known as wrapping. The next one is false twisting. We produce a yarn by the process of false twist, that is by generating false twist and making the fibers to wrap around the yarn. The other one is rubbing. By rubbing action, we try to insert twist into the yarn. Then there is a process which is adhesive process, that is, in this process we will be binding the fibers with the help of adhesive. And then the last one is felting technology, that is, a felting process is there through which the fibers will get stuck to each other. So, these are the various means which are used to produce yarns, and the set of technologies that exist, we call them new spinning technologies. We will learn each of them in more details. Now, in open end spinning, we have rotor spinning, then we have friction spinning, and we have vortex spinning. Under wrapping technology, we have a system which is known as parafill spinning system. We will learn about them in details later on. In parafill spinning, a filament is wrapped around a bundle of fibers. Then under false twist principle, there are two methods which are available: air jet spinning and also friction spinning. So, you can see that friction spinning is here and friction spinning is there. As we go through the course, you will learn why friction spinning exists under open end spinning system and also under false twist spinning system. Then by the process of rubbing, the technology which is commercially known as Repco spinning system, mostly used for wool fibers. Then the adhesive process that has been developed is known as Twilo or Bobtex spinning system, and the felting technology that we have is known as Perilock, is the name of the spinning system, Perilock. So, you see that spinning technologies can be really classified into 1, 2, 3, 4, 5, 6 different groups, and you are going to learn about them in more details gradually. But out of all these, some of the spinning systems are very popular and commercially very successful. So, the emphasis will be more on those systems which are commercially successful and also running in the industry. Now, the question that comes to our mind is, what are the advantages and disadvantages of new spinning technologies? The general advantages are high production rate in most of the cases. This is in comparison to the conventional spinning system that we have, that is ring spinning technology. Then the next advantage is elimination of process stages. You are all familiar with the ring spinning process. The ring spinning process is pretty lengthy process. There are so many machines which are used, and the fibers have to go through a long chain of processes before they are converted into yarn. So, if we can cut down few processes, there will be great advantage in terms of saving of space, saving of capital, saving of labor, saving of energy. So, that is why any shortening of the process will be advantageous. And then the other one is that easy to automate. Automation has come in a big way, and most of the machines are getting automated, and these machines are easy to automate. Against this, the disadvantages are yarn character is different from ring spun yarns. That is the disadvantage, and we will see why, if the yarn characters are different, why it will be a disadvantage. This we will come to know as we go through the course. The second point is limited count range, that is the count that we can spin on any of these systems is very limited. Ring spinning is most flexible spinning technology from the point of view of range of counts of yarn that we can produce, from very coarse to very fine. But the new spinning technologies, you will see that some of them are suitable for coarse count, some of them are suitable for medium to fine counts. That is the disadvantage that we have with the spinning systems. And the third one is greater demand on raw material characteristics. Ring spinning that way, as I say, is a very versatile spinning system. It can handle all types of fibers. It can produce a range of yarn counts, and the character of the yarn also is superior in many respects. That is why even though the ring spinning is slow in comparison to the new spinning system, even then the ring spinning is still most popular spinning technology till now. Now, in the new spinning systems, you will come to know gradually that the demand of the raw material characteristics is quite high, that some of them can handle shorter length fibers, some of them can handle long length fibers, or some of them may need little finer fibers. They may not be able to tolerate too much of dust. So, these are some of the limitations of the new spinning technologies, and therefore, there is a great demand on the raw material characteristics. Now, shortcomings of ring spinning technology that we need to know. What are the shortcomings? The first one is underutilization of winding potential. What does it mean? We will discuss them in details. Second is necessity to rotate a heavy package to insert twist into a tiny group of fibers. In the ring spinning, we will see that we have a big spindle which is quite heavy. Then on the top of the spindle, we put a bobbin. Mostly nowadays they are made of plastic material, and we need to rotate this heavy spindle just to insert twist into a tiny group of fibers. How many fibers are there in the cross section of the yarn? It could be 200, 300, 400 or 100 in this range. But just to put twist, we have to rotate a heavy package which includes the weight of the spindle also. Next is raising production speed, if we try to increase, leads to one is frequent end breakages. That means, we will not be able to raise the speed too much. We face this problem, that is the breakage rate will go high and therefore, there is a limit to which we can go. The other one is shortening of traveler life, that is, if we go for higher speed, the traveler is made to rotate also at a faster rate, and therefore, the traveler life is shortened. If it moves at a faster rate, there will be a lot of abrasion between the traveler and the ring, and the traveler will be pressed against the ring with a higher centrifugal force. So, friction will be quite high, and as a result the abrasive damage will be very high and very quick. As a result, the traveler's life is shortened. Then the other difficulty is difficulty in manual piecing. In case the end breaks, we have to join the end with the fibers which are being fed from the front roller. This process is known as piecing process. So, if we go for higher and higher speed, manual piecing becomes more and more difficult. That is, the failure will be more and more, and hence there will be loss of productions. So, this is another difficulty with the ring spinning technology. Frequent doffing of cups. In the ring spinning, the package size is very small and tiny, and how much yarn it holds? It hardly holds 70, 80 or 150 gram of yarns. It gets filled up. So, the actual content of yarn in the cup is very limited. Whereas, you will find that in the new spinning technologies, the package that we produce can really hold a large quantity of yarn, which may go up to 2 kilo, 2.5 kilo. So, that is a big advantage, and if the content of the yarn is less, that means the cups will get filled up very fast. So, we have to stop the machine and replace the full cups by empty cups. This process of replacing the full cups by empty cups is known as doffing process. So, frequency of doffing will go up, and as a result the production loss will be there. Whenever doffing is happening, we have to stop the machine and remove the package, replace it by a fresh package, which will take some time, and if the machines are quite long or so many spindles on which we have to work, as a result the overall production loss is there. And the last one is excessive fly liberations. This is also a serious problem. That is, fly mean very short fibers which will be coming out from the front roller nip will really increase in quantity, and the fly will contaminate the atmosphere. And the second thing, the fly will get picked up by a rotating yarn balloon, and it may cause naps. The fly will also fall and settle on the ring, on the machine, and therefore, there is every possibility that as the yarn is being spun, the balloon will pick up these fibers which are floating around, and this will going to create some kind of fault in the yarn. So, this is also a serious problem. So, these are the problems with the ring spinning technology, and there was always a thinking in the mind of the researchers that how to enhance the production speed, and ultimately it was found that there are some inherent flaw in the very principle of ring spinning. We will see that now, as it was written in the previous slide that underutilization of winding potential. So, how? Let me explain it now. Let us take an example in order to understand this. Spindle speed, let us say, is 18,000 rpm. Bobbin diameter is 22 mm. Front roller speed is, let us say, 250 meters per minute, and front roller diameter is 28 mm. With this, the front roller delivery is going to be 17.6 meters per minute. That will be the delivery rate. We know the bobbin, we know the front roller speed, and we know the diameter of the front roller. So, we can find it out typically. This is the typical delivery rate from the front roller of a ring spinning machines. It may vary between 15 to 20 meters per minute, depending upon the yarn count and the kind of twist we are keeping in the yarn. Now, let us look at the bobbin speed now. Bobbin surface speed is how much? If the spindle speed is 18,000 rpm and bobbin diameter is 22 mm, the surface speed of the bobbin is going to be 1244 meters per minute. That means, the bobbin is capable to wind so much of yarn. The surface speed is 1.2 kilometers per minute. In a minute, it can actually wind 1.2 kilometer. But how much it is actually winding? Only 17.6 meter in a minute. So, what is the utilization of bobbin surface speed? 17.6 by 1244 into 100, that gives you a figure only 1.41%. So, even though we are turning the bobbin at a speed where it is capable to actually wind 1.24 kilometer of yarn per minute, it is only winding 17.6 or close to 18 meters per minute. That means, the bobbin surface speed utilization is only 1.4%. That is why we say that underutilization of winding potential. The other problem is, as I said, traveler speed. Typically, the speed of the traveler could be 30 to 35 meters per second, limiting speed. Some companies may claim that it can go up to 40 meters per second, but generally if we go to the commercial level, usually the speed that is kept is around 30 to 32 meters per second. That is the typical speed of the traveler. This is the surface speed of the traveler. Now, what happens? Traveler creates micro wales with the ring surface. At it turns, there is a metal to metal friction. The wales breaks, creating roughening of ring surface. Roughening of the ring surface increases frictional heat, and therefore, the traveler becomes very hot, and that changes the very surface characteristics of the traveler. As a result, the traveler life shortens. This is what will be happening. So, heat generation depends upon the third power of traveler speed. A small change in traveler speed will increase the heat too much. Traveler are supposed to dissipate the heat, and what are the mechanism that is available for the traveler for heat transfer is only conduction and radiation. So, conduction is between ring to traveler. So, some conduction will be there, and the radiation could be from traveler to the all the it could be to the air or to all the machine parts. So, that is how the traveler can lose heat, but point is the heat generation through the frictional heat generation is much more than what it can dissipate, and as a result the traveller temperature keeps on rising. So, very high speed we cannot attain, traveller life will be shortened. In the traveller life shortens, the end breakage rate will go up and one has to stop the machine, remove all the travellers and replace them by new travellers, which is also a loss of production. So, that is the issue that we cannot go for very high traveller speed because of these reasons. A design limitation of ring spinning. In the ring spinning, the twisting and winding operations are inseparable, that is, we cannot separate them out. The spindle is the prime mover, it rotates and it transmits rotation to the traveller, and the traveller as a result runs on the ring. The traveller running around the ring is going to insert twist into the yarn, and the traveller running around the ring also causing winding. Spindle is rotating, traveller also is rotating, both of them rotates together. The bobbin is on the spindle, that means the bobbin speed and the spindle speed are exactly same. So, bobbin rotates at the speed of spindle, traveller also rotates at the speed of spindle, not at the speed of spindle, sorry, traveller will rotate at a lesser speed than the spindle, that is, the traveller will always lag. The lagging of the traveller is because of the friction between ring and traveller, and the other thing is due to the continuous supply of yarn to the traveller from the bobbin, and ultimately the yarn is going on the bobbin surface. The yarn is supplied from the rollers, and the same yarn is passing through the traveller, and finally it is going on the bobbin surface. Therefore, this friction as well as a continuous supply of yarn makes the traveller to lag behind the spindle or lag behind the bobbin, and this lag is the reason for winding the yarn around the bobbin. Unless there is a lag, there will not be any winding. Fortunately, the lag is just enough to wind the yarn that is continuously delivered by the front pair of rollers. Anyway, the twisting and winding process in the case of ring spinnings are inseparable, they are happening together. Drafting, twisting and winding, these are the three processes which are happening together. If we want to think that we have to go for high speed, then there is a need to separate out twisting and winding process, that is, they have to be independent of each other. On the ring spinning technology, they are not independent of each other. The same element is responsible for twisting as well as for winding. So, the process, these two processes are inseparable. If we can separate these two processes, make them independent of each other, then there would be a possibility to raise the production rate phenomenally. Now, if we want to achieve that, what we need to do? Okay, let us first see that if I want to have an independent twisting unit placed between the fiber delivery which is here, and suppose this side is a winding unit we have, and from the left hand side the yarns, the drafted fibers are being fed, and there is a twisting unit over here which is twisting the bundle of fibers. If we have a system like this, what will happen? This twisting unit will actually start working as a false twister. If you are familiar with the false twisting process, then this is exactly will be a false twisting process, because there is a continuity in the supply of fibers from delivery point to the winding point, and these fibers are overlapping on each other. So, there is a continuity and there is a overlapping of fibers. As a result, whenever the twisting unit starts putting twist, on the left hand side if we get Z twist, on the right hand side we will get S twist, but then the yarn is flowing continuously. The Z twisted part of the yarn will go as soon as it arrives on the right hand side, it will cancel out the twist on the right hand side which is S direction. So, Z direction twist will nullify the S direction twist which will be there on the right hand side of the twisting unit, and as a result what will happen, on the right hand side we will only get parallel array of fibers. And if it is a parallel array of fibers, this will have no strength. So, there is no winding possible at all. So, if we think of a process like this system is not going to work at all. So, what is the way out? That is what had exactly been done in open end spinning. That is, the fiber supply which is there, that is fibers are supplied maybe by a pair of rollers. We have to give a very high draft, and the draft is so high that the fibers number in the cross section will keep on reducing, and it will reach to a stage theoretically which will be almost single fiber flow. At that stage we have to reach. So, that a very high draft we have to apply, hoping that the number of fibers in the cross section of the fiber flow will keep on reducing, and it will reduce to a level which is close to almost single fiber flow. And if we have a twister placed here at a distance as is shown here, the twister rotates. What will happen? If the twister is putting, let us say, Z twist in this directions, the twister will put S twist in this direction only, but in this direction as soon as the fiber will arrive, the fiber will get assembled at the twisting point, and once the leading end of the fiber is picked up by the twist at the twisting point, the trailing end can rotate freely, and whatever S twist could be there on the trailing end, that will be lost. So, on the right hand side the fibers will be Z twisted. On the left hand side, as soon as the fiber arrives and get picked up at the twisting point, the front end is picked up, the trailing end of the fiber is free to rotate now. So, the torque which the left hand side of the fiber is receiving is actually getting released, because it is free to rotate, and therefore, we will not find any twist on the left hand side of the twisting point, because the fibers will be trying to freely rotate and release the twist, whereas on the right hand side the fiber bundle will be twisted in Z directions. So, what has been done? Disruption in fibers overlapping. So, the fibers are not really overlapping on each other. That much amount of draft we have to provide. Here many fibers are overlapping on each other. By drafting, by means we are stretching, the number of overlapped fibers is gradually reducing, and when we come to this stage, the number of overlapped fiber is nil, almost single fiber flow is there. That means there is a break in the continuity of fiber supply. This break is very necessary. So, fibers are moving at a high speed, and then at the twisting point they are arriving, and this they have to arrive, they have to slow down, because we need to have, let us say, 100 or 200 fibers in the yarn cross sections. If there is single fiber flow, the velocity of the incoming fiber and the velocity of the twisted yarn should be so balanced that at any point of time there will be 200 fibers available at the twisting point, so that we can produce a yarn of the desired count. So, fibers have to be slowed down. They will, incoming fibers will be coming at a higher speed, the break will be there in the continuity of the fiber supply, and then fibers will be reassembled at the twisting point. That basically means whatever number of fibers are required in order to produce a yarn of a certain count, that many fibers will come and arrive there, and then all these fibers will be twisted together. The right hand side will get the desired twist and in the desired directions. On the left hand side, the fibers end, because they are free to rotate, they will lose twist and they will remain untwisted. This is the basic principle of open end spinning. So, as a result of this, what are the benefits? One is high speed of twist insertion. The twist insertion unit, or you can say the twister, can be rotated at a high speed. We can have a small twister, not like a big one like a spindle, not so heavy. We can have a very small unit which can rotate at a very high speed and consume much less energy. Then the other advantage is low power consumptions per kg of yarn productions, because we are not rotating a heavy twisting unit. Twisting unit can be made very small now, and therefore, lot of saving of power, and therefore, power consumption will be much less. Larger delivery package size can be quite big, because now in the ring spinning the package size is limited, because the package has to stay within the balloon. So, and we cannot, if we want to have a big package, you have to increase the ring diameter. That will create, if we have increased ring diameter, the balloon tension will increase, the yarn will break, and if we increase ring diameter, the number of rings that we can accommodate in a given length will be much less. So, number of production positions will go down. The main problem will be the breakage of the yarn, because larger ring means lot of tension in the balloon, the yarns will break. So, large package we cannot have in ring spinning, whereas here there is no such limitations. The package size which is cheese, I can make it 1.5 kilo, I can make it 2 kilo, I can make it 2.5 kilo, whatever is convenient we can have it, and we have no problem there. elimination of some processes. We will see that we do not need combing operations, we do not need speed frame, that is roving frame. These two processes are not required at all. Possible to use cheaper material, especially in rotor spinning system, we can use cheap material, that is material, that means fibers which are shorter in length. This is only true for rotor spinning. No twist variation from empty to full package. In ring spinning, the ring cop, this possibility is there. Twist may vary from empty to full package. There is a chances of twist variation could be there. Here this is not true, because there the traveler speed is not constant, it is continuously changing, and hence twist can vary in ring spinning, but it will not vary in rotor spinning systems. No drafting wave in the yarn, because the roller drafting will not be there. We will see that how the material of this fiber is drafted. We have eliminated the roller drafting unit, and hence the drafting wave generation is not there, which is otherwise possible in the case of ring spun yarn. Drafting wave can be generated on draw frame, it can be generated also, it can generate on your roving frame, also possible on the during ring spinning itself, the drafting system. So, at different places the drafting wave can generate. Here this possibility is almost nil, though we will be fitting a drawn sliver. So, cart sliver, when we drop them on the draw frame, there is a chance of development of drafting wave there, but beyond that in the spinning process there is no scope for generation of drafting wave. So, with this we now come to the open end spinning, as we have discussed earlier, that we will see that this principle is used in the case of rotor spinning. Rotor spinning is one machine where the spinning actual yarn formation principle is open end spinning. So, we first take up this, and this is one of the most successful spinning technology. Now, block diagram of rotor spinning process. So, if we look at the rotor spinning process, first there is a sliver feed, some arrangement by which sliver will be fed. Next is fiber separation and fiber transport. We have to, as I said, we have to stretch this sliver, so that we have to introduce a break. Then comes fiber accumulation and twisting. After that we will have yarn withdrawal. Very twisting means the yarn is forming at this point. Now we have to take out the yarn. So, yarn withdrawal has to be there, and then we will have a package formation, that we have to form a package. So, this is the, you can say, the various units of the rotor spinning: sliver feed, fiber separation unit and fiber transport, fiber accumulation and twisting by a twisting element, then yarn withdrawal, and then package formations. Here a diagram is shown here, you can say cross sectional view of the open end spinning, rotor spinning especially here. We will discuss about them in more details gradually. That sliver is here, we are feeding, then the feed roller is here, feed plate, this fiber is drafted, it is going like in this here, this is the passage of the fibers. Here is the yarn. So, a simple sketch of the spinning process is shown here, sliber, feed roller, then there is opening roller. The opening roller is actually acting as a drafting unit. We will discuss about them. So, rotor spinning machine, if we see, we have a feed unit, where sliber is fed, then from the sliber fibers are separated, and then fibers, separated fibers are transported. This is the part of the feeding unit is doing this job. It is pulling the fiber, feeding it, then fibers have to be separated from each other, and then the separated fiber needs to be transported. The entire feed unit actually doing these jobs. Then comes the twisting unit. Twisting unit consists of a rotor, which is a twister, a doffing tube, a take up roller, and a suction system. These are all there in the twisting unit. In the winding unit, we have delivery roller, a winding drum, a traverse guide, package, doffing. Then we go to the suction unit, where we have external suction pump to draw air. Fiber transportation is done by the help of air. So, it is all pneumatic transport of fibers. We will also look at the pneumatic transport in details. So, you can say the machine has 4 units: feed unit, twisting unit, winding unit, and a suction unit. And with that, we close the very first lecture on this topic, and in the we will see that in the next lecture we will take up each of those units one by one and discuss them in more details. So, I hope you have understood what are the main shortcomings of ring spinning technology. This is very important to know, but what are the strength of ring spinning also we should know. The second thing is, what about weakness is there? If we want to get rid of this weakness, what we need to do, and that is exactly what has been done by developing this rotor spinning technology. And then obviously, I have just introduced you to the rotor spinning technology. Now, in the coming lectures, we will know more and more about rotor spinning. Thank you.